Alright, coming down the home stretch here, most likely our last unit, similar solids. If this is the year 2020, this is our last unit. Congratulations, you did it. If it's not, you're probably pretty close to finishing geometry. So, congrats. So let's get to it. Alright, so we know about similar figures. Similar figures have the same shape, but not necessarily the same size. So similar solids are the same thing, same shape. Alright, you can scale them up or down, but they could be different sizes. And, most importantly, the corresponding lengths must be proportional. Also, any angles there are going to be congruent, just like similar figures. So let's look at the right cylinders on the right. Are the solids the same type of solid? Yeah, they're both right cylinders, so we're going to say yes to that. Okay. Are the corresponding lengths proportional? Well, let's compare them. Let's look at the heights. The heights would be 12 over 8. The radii would be 6 over 4. Alright, both of those simplify to 1.5. So yes, the lengths are proportional. Alright, so what's the scale factor from 1 to 2? Alright, now, if it's written like this, from 1 to 2, it's like, what would you multiply the lengths in 1 to get the length of 2? Alright, so if it's written like that, since it's getting smaller, we know that our number should be less than 1. So whenever the figure gets smaller, the scale factor is going to be less than 1. Alright, so that's 8 over 12, which would reduce to 2/3. So that's going to be our scale factor from 1 to 2. Alright, quick question, pause it after I ask the question. What would be the scale factor from 2 to 1? Alright, cool. It would be 3 to 2. Alright, nice. Okay, so let's kind of look at that again. Let's look more into similar solids. So when two solids are similar, we can write their linear dimensions as a ratio of their areas. Their linear dimensions as a ratio, their areas as a ratio, and their volumes as a ratio. There is a relationship between all three ratios. Alright, using similar solids above, calculate the following ratios, then fill them in on the table below. Be sure to simplify each ratio. Alright, if you want to try that right now on your own, please do so. And then you can pause the video, and then when you unpause it, I'll talk through each answer. Alright, so let's talk about what we found. First, I didn't write units by each measurement because I didn't have enough room, but I wrote them on the left in that darkish blue. So height and perimeter, you're going to measure those in units like feet or centimeters. Surface area, that's going to be square units like square inches, and volume is going to be in cubic units like cubic meters or whatever. Alright, so if we look at the ratio of the heights in the top column, alright, that's going to be our scale factor. So when we divide 12 over 8, or even if we divided the radii in the cylinders, we would get 1.5. Alright, the heights have a ratio of 2 to 1. Same thing with the base lengths and also the scale factors. So these are similar pyramids. Okay. Now if we look at the perimeters, and we found them independently of the heights, like just found the perimeters and divided them, we know that we see that they also have the same scale factor. So since heights are measured in units, it's a length. Perimeters also measured in units, it's a length, it's a collection of lengths. Notice how the scale factor, so the top row, is the same ratio as the next row. Okay. Now if you look at going from height, so scale factor, the top row, to the third row, a ratio of areas, alright, 1.5 to 2.25, take a guess at that connection. Same connection between 2 to 4. Alright, that connection is that it's squared. So to go from the height, the scale factor, ratio of heights, to the surface areas, you square the scale factor. Same thing, if you know the scale factor, 2, the ratio of areas is going to be 2 squared, 4. Alright, now since volume is measured in cubic units, if you know the scale factor, the same thing is going to happen with the ratio of volumes. That's just going to be the scale factor cubed. Alright, same thing happens, I wrote over here because of the watermark. Alright, if you know the scale factor is 2, so you double all the sides, the surface area is going to get 4 times bigger, 2 squared. The volume is going to get 2 cubed times bigger, it's going to get 8 times bigger. Alright, so let's look at that relationship more in the next video.